All right, guys, keep going with this car. I put everything back together, but the car is still a no start. I went and tried to do a relearn on the valvetronic, and I get um, fail. So I'm getting this code, which is 135.608 valvetronic system, no movement identified. So I have my Picoscope connected. This system uses a three-phase motor. So I have, let me see if I can show that in here. Sorry for the uh, shaking and movement. This is as much. So in the center wires are the three heavy gauge wires. The rest are just 5 volt reference, a ground, and like 5 sensors per position. And the internals, which are the three big heavy wires, are the three phases of the motor. As far as BMW information, what it says is, 1 second, guys, let me show it on the computer. I'm using Identifix for, so what it says is just, do the Baltronic run-in procedure, which I try to do, but since there is a code, I cannot follow the procedure. So let me go back to my bookmarks and sorry guys, I'm going everywhere. I want to try to show you. Well, let me show you also this. I think is function description. Let me see. No, actually, it is in here? No. Scope pattern. This is good about the Identifix. It gives you a little bit of a help on how the thing should look. Um, it says about the three phases, and as you can see here, U, B, and W is a three-phase motor. So let me just move this a little slow so you guys can read it. And that's what, ISTA is supposed to telling us. Um, Electronic fold patterns. I think this is what it says in here. Let me see. Yep. That's what I wanted to tell you on the second video. After the engine is stopped, the section shaft is in the maximum stroke position. So you make sure when you adjust it to put it there, and that's what they tell you to use a open wrench and move it around, and the Allen key on the Valtronic motor itself, and put it into the maximum stroke. Well, so I tried all this and didn't work. So one thing that I have noticed is I right now have the ignition on. As you can see, the power. I'm gonna just let me stop this. So at least probably not the best capture right there. Let me at least read the red one. It's in 14.4. So hopefully you guys right here. So 14.4, and if I move um, a cursor into each one. It's around the same. I'm trying to just put it as close as possible. It's not going to be perfect, but you can see that they all have the same voltage. And this is with the ignition on. Just stays there. It doesn't do anything. But some of the procedures tell you to, switch the ignition off and wait for the Valtronic relay to go into the low position. And you'll see, oh, let me actually put that on running, you will see exactly what happens. And like as soon as the relay disconnects, I can see a movement on the motor and it's audible. You can hear it moving. So the voltage is steady on the lines, three phases. Takes like 20 seconds to deactivate right there. And you see all the movement. So let me stop the capture, go back. I'm playing with the wrong button. So the capture 7, let me take this cursors out. We don't need them now. And I'm trying to do a zoom so you guys can see how this looks. And this is how this looks. So I don't know why. Let me do this again because I went too far in. We don't want to be that far in to see the actual waveform. That's better. Okay, so that's how this looks. I think that's a good capture. And good thing from Pico, you can deactivate the channel. So the A channel, which is the one that's active, is the blue one. As you can see now, blue is active. And in here, right here, green and red are not active, but then red becomes active, and so is blue. So the blue and the red are active, and green is not. I'm trying to scroll forward so you guys can see the changes. So still green and, sorry, red and blue are active. Now just the red right here, as you can see from the blue when high is not active, and only the red, and that's the way the motor is being moved. That's like the one phase controls 120 degrees of movement, and so is the other phase, and so is the other phase. So I'm trying to do it, not the right thing. So this is the red only. We got only red, and this is a transition. Probably this is the last. Well, you can see it went from red to green. I'm just showing you my captures, and I have seen, okay, now we have blue and green, and before it was red and blue, and that's what it does. So why is activating the motor with the ignition off? But as soon as I turn the ignition on, like right now, all the signals, let me take the zoom off. Like if I put a cursor onto the green, it's pretty much slow. So what is this? It says minus 1169. Huh. Yeah. Oh, millivolts. I was reading like, wow, minus 11 volts? No, so we're pretty much in zero. If we read the blue one, remember I'm not probably exactly on the zero. I'm sorry, I'm trying to put the cursor in there. So we have 8.19 millivolts, so we are in zero. I go and try to set the ignition on. And all it does is just goes high. So now, if I read the blue channel is in 14 volts, and the green channel is in 14 volts, and it's the same. So we have movement. I cannot do a relearn. The ignition is on. If I go here, and I do an ISTA to calculate the test plan, it's going to try to do the activation for the valvetronic. All I can hear and there is the um, total valve trying to open. It's telling me to switch the ignition off, blah, blah, blah. I don't need to do that. I already did that. Does the engine start? Well, no. But look at the weird. Does the engine of the vehicle start? The starter motor rotate? Well, the starter motor rotates, yes, but no, it's not no start. But if I click the other one, it's just check your power. So in the following steps, a attempt will be made to activate that. So I will do or try to do a 6 thoughts or 6 runs. And here we'll try to run it, but it just tells me switch off because it's no activation. And then it tells me to switch the ignition off and wait for this start stop button to go off. And that's when the um, valvetronic will move as soon as that ignition goes off. Let me show you that again. You can hear it. I mean, and you can see it's moved and it went down. So that's what it's supposed to be. Switch off the ignition and terminal R way until the main relay has dropped out, which it is, and then switch the ignition on again. This is the relearn. So I put the ignition on. I click next, next, nothing. It tells me to do the same thing again. And it goes like tries and try, and then it says fail. So I'm gonna have to do more homework, or for me, it's either this motor bad, it's like too much for the computer. I don't know. It's like this is like I have no help. It's very minimum information here. So I called my friend Keith. He's actually working in one of these cars at the same time I'm working on, and let's see if he can come up with something because he's a guru on this all these kind of problems. We'll see. All right, guys, following up on this problem, I went and now I am reading the position sensors. This motor has 5 position sensors, which they share the power and the fiber reference and the ground. And this is the way the computer knows where exactly the motor is. So I narrow that one of the wires, which is the yellow red, is not producing a signal; it's staying low. So let me show you the diagram. So we have, as you see here, let me make sure. So we have a blue wire, which is the 5 volt reference or sensor supply voltage, which is a 5 volts. Then we have a black wire, which is the sensor ground. And then we have a yellow sensor signal, yellow blue sensor signal, yellow red sensor signal, a white, which is a sensor signal, and a yellow white. So I identify those. I save the capture. So we have in this one, we have the yellow white, yellow blue, and yellow red. Red is on the channel C, which is my green channel. And as you can see, we have signal on the blue channel, on the red channel, but the green channel is staying low, which right here is reading 11.59 millivolts, which is, let's say, 0 volts. If I go over to the next capture, which is this one, I'm sorry, I have to actually click on it. All right, now we have, as you can see, we have on the blue channel, we have the yellow wire. On the red channel, we have the white wire, and I kept on the channel C, which is the green channel, the same yellow red, and that stays low as again. It's in like 19.46. So we have no signal on there. So my next procedure, which I already checked before, but I have to double check again, is this wire shorted to ground? I disconnect the wiring from the motor to the DME before, and I check each of the lines for continuity, and all of them pass. There was no continuity in between. I can, pretty much peel off the conduit, and all the wires are perfect. So, but again, I gotta double check that. So that will be my next step. All right, yes, guys, to add a little bit more info, I'm a little tired. I'm trying to decipher this car. So I want to show you that it is 5 sensors on this servo motor, which are built in. So the Valvetronic servo motor is supplied by the digital engine electronics with 5 volts. 5 Hall effect sensors provide the digital engine electronics with signals. Of the 5 Hall effect sensors, 3 are used for approximate identification and 2 are for detailed classification. This means that the engine that the that means that the angle of the rotation of the valvetronic servo motor can be determined at almost 7.5 degrees. So as you saw, one of those sensors is not reading. So my next test, what I did is I removed that yellow-red wire from the connector itself with the ignition on that goes straight to 5 volts. What that tells me is integrity of the wiring from the computer to the motor is perfect. And this is the only one that is going and it stays low. It's like 19 millivolts as you saw before on this same video. So I'm calling this Valtronic motor defective. It is moving, but the sensor is not reporting correctly. And it has to be all working. Otherwise, the computer is reading no movement. Even that the motor is moving, it's not being seen by the computer because one sensor shorted to ground or not producing a signal. So it's not, I mean, it's really not shorted to ground, like I said, because it's just staying low. The wiring is clean, so I'm going to call or ask for another motor. Well, so let's stay tuned.